The purpose of the lesson was for students to understand the relationships between two parallel lines cut by a transversal and the angles that they formed.
What you're going to do, and I don't have a ruler, but I've got this thing over here. Here's your patty paper.
We started with a patty paper investigation. The students had to draw two parallel lines, then cut those parallel lines with a transversal, which then created 8 angles. Then we took those, cut them in half, and I wanted them to compare the measurements between different angles and find special relationships, which they did.
Yeah. So just kind of gently. This is what you have, right? Yes. This was your first parallel line. This was the other one. What I want you to do are take angles 1, 2, 3, and 8 and slide them down on top of the other angles and see what you notice.
And then
Is that true?
I asked the students to
All
flip
the
the
angles
paper
are
around,
congruent.
upside down, or the paper actually upside down, or just the angles upside down, so that they could also find other relationships besides the ones that just laid right on top. And many kids found those on their own, and many found it by watching others.
Because I guarantee you it's one or the other. Now look at the one next to it. Is it obtuse or acute? So are they the same?
No.
No. So all the angles are not congruent.
The diagonals are congruent.
Mama D, you need to pay attention back. All right, so let's readjust our thinking. I'm hearing angles are congruent, but they're obviously not all congruent. Which angles are congruent? Somebody raise their hand and give me a pair.
1 and 3.
So,
I can't even read.
1 and 3. He says 1 and 3 are congruent. You saw that by lining them up?
Yeah.
So you've got 1 and 3 on top of each other?
No, 1 and 5.
Okay, I'm not saying 1 and 3 aren't congruent, because I think they are. But why are they?
Because they're diagonal. Diagonal. No, because they're vertical.
Which is created by parallel lines. So I agree, 1 and 3 are definitely congruent. But when you laid them on top, it was 1 and what?
1 and 5. Or 1 and
Did you write too small?
Yeah, I did.
Write a little bigger and we'll come back to you. Somebody else look at them. Okay, Violet says 1 and 7. Does anyone else see that?
Yeah.
Because I'd really like everyone to agree or disagree. Micaiah? Are there any other angles that are the same? If you twist this thing around and play with it some.
It's like 1 and 5. It's like 1 and 5.
1 and 5 are the same. Why? When you twist it around, they're the same? Anything else?
8 and 4.
1 and 5.
2 and 6.
2 and 6.
8 and 4.
Yeah, 8 and 4.
And 3 and 7.
Beautiful. Well, you guys found a lot.
The numbers changed,
But they stay the same as each other. Yeah.
Okay, the next part of the lesson was to use
But you didn't know
the laptops. It's a GeoGebra program where there's an applet up with two parallel lines and a transversal, and they are set at 90 degrees for each angle. And then you grab the vertex and with the mouse and the pointer, and you can actually pull the angles to different measurements, and it will show how certain angles remain the same and certain angles will be supplementary. And I had a handout where they could actually start with the basics. For instance, what do you notice about the pink angles? What do you notice about the blue angles? Which led them piece by piece to bigger problems.
And everyone's responsible for filling in that handout. But if you need a partner to help you understand some of the things, you may wish to talk to each other. Just pay attention to me for a moment, and then I'm setting you free. At the top, you guys, it shows you to load this tool. It's already in there, right? Okay. It says to use that to answer questions. Guys, you can move the red point around. Just taking it and spinning it or flinging it back and forth real quick is not going to show you a whole lot, right? Ronald.
No matter what degree you put it at, they all equal 360.
Oh, I see. So no matter how you move it, all four in a... Yes, they do. Okay, they're exactly precise measurements. They certainly are. Violet, Wesley, shush.
The angles that are next to each other equal 180.
Does that always happen? No matter what you do to it?
Yeah.
Yeah. If I have this angle up here, does anyone know where another angle would be that would have exactly the same measure? Well, get your hiney up here and draw a little asterisk in it.
Would it be here?
Are there any more?
Here? Oh crap, sorry.
It's all right. It's perfect. Okay. This angle, is it the same as the star? No. So Violet, what would this have to be so it could be the same as the star?
Would be the same as the star?
Mhm.
90.
90. Perfect. Come on. I'm not even going to do it. Need you to go. You won't keep going, you'll leave.
What are you talking about? I'm looking.
Good. That is perfect. Perfect. The question is, what is a star and a box? Violet.
180.
In what way will they be 180? What would you have to do to them?
Their angles would be different unless they were 90.
Right, but what I'm asking is what operation has to take place?
Addition?
Yes. Yeah, you'd have to add the angles, and then they would be 180. What's the word that means 180, Ronald?
Isn't linear pair or supplementary?
Well, linear pairs are supplementary. But are all supplementary angles linear pairs?
No.
No. Okay. Okay, so up here, does everyone agree that this is true? How many different measurements could I get for those 8 angles? Could I have 8 different measurements? Could I have 7? Could I have 6? How many is it possible to have? Yes, 2 is exactly right. So if you know one, you know them all, don't you? So let's just start here. If I tell you this is 110 degrees, what else do you know?
I know this equals 180.
Okay, so I bet you could find it.
This equals 180. 7.
Write it in. It's good. Do you know what's vertical, that 70-degree angle? What did we just say vertical was? They're opposite on an X. So look at that 70-degree angle. Tell me what's opposite on an X.
Oh.
Perfecto. Beautiful. Nicely done. What do you have for the measure of this angle right here on your paper? 81. Well, assuming this one's the same. Assuming this one's the same, how can I find the last angle up here?
Could you subtract that from 110?
Subtract what from 110?
81.
Can you tell me why you would?
Because aren't those the same measurements on each side of the X?
Yeah, what do we call those?
29.
Okay. Does that help you guys with the problem you have? Sierra? They're transversal. So if this is 29, what's this one up here? 29. What's this? What is it? Be careful. These are a linear pair.
151.
It is 151. How'd you get it?
180 minus 29.
Okay. Remember, we took this, we cut it in half, and we laid them on top. Remember? Beginning of class. We took the 2 parallel lines, we cut them in half, we took this, laid it on top. What's this measure? 151. What is this measure?
151.
What is this measure?
29.
And this?
It's 29.
Okay? It's the same all the time. If they add an extra line, an extra transversal, try to block out the information you don't need. Okay, we are getting really close to the end. I need you guys to finish this handout. I've also got a homework sheet, but I need to go over how to do it.